let's run the experiment. So what's going to happen now is we're going to have to do this pretty quickly to run through each of you 15 guys, okay? There's a catch, though, in this. Victor, let's start with you. Choose a cup. Stand up and choose a cup.
I thought, sir, you're going to put the 2 rand in the
No, don't pick it up. Choose a cup. Just touch it for me. And I'm going to go through exactly the same process for all of you guys, so try and make it quicker when I do this. Okay, Victor chooses this middle cup. Now what I'm going to do is I'm going to say it does not exist in this cup here. So now my question for you is, do you want to change your mind or do you want to stick with it?
Stick with it.
You want to stick with it? Okay. Now I'm gonna reveal now. You can sit down. Okay.
I can't sit down.
I'm gonna do this exact same process for every single one of you guys. I'm gonna record on the board what happens. Okay. All I'm gonna record though is where the chocolate actually is. So whether you right or wrong, I'm not going to record. I'm going to record if you should have swapped or if you shouldn't have swapped.
Oh,
do you agree? Okay, so that's what we're having a look at today. Yeah.
Okay, that's what I wanted.
Okay, so unfortunately you got it wrong. So should he have swapped?
Yes.
He should have swapped because the coin is sitting there. Okay?
I thought it was a chocolate.
So I'm going to put a 1 under swapped. There's the chocolate. The chocolate is represented by the coin. Okay, I need your hand now, Victor. You're going to have to come and just shield the table from the rest of the class while we set it up. Can you just hold this in front of everyone? Set it up. And then we're going to go quite quickly. Okay, so can you reveal? And Rex, choose a cup. I'm going to reveal that one. Would you like to swap?
Unfortunately.
No swap. And he gets the chocolates.
Oh, buddy.
Okay, so catch it.
Yes, right.
Catch your wake up. Alright, so guys, the no swap was correct.
Let's hope it's a 50-50 choice.
Nice thinking, Giovanni. I like the way you think. Alright,
You're not going to get it right, mate.
guys, try come up quickly. Let's just move through this because we got limited time. Choose a cup. Choose that one. I'm going to tell you that it's not under that one. Would you like to swap or not swap? You're keeping it. Unfortunately, you're incorrect. And it's under that one. Okay, so Lorato should have swapped.
Lorato?
The swap is piling up.
Oh, it's still fairly good.
How do you help somebody when you don't know what the answer will be?
Choosing the middle one. I'm going to tell you it's not under the right one. Would you like to swap? No. Yo, none of you guys swap, eh? And you're incorrect. Okay. Come in.
No, it's all about choice.
It's all about choice. It's all about choice.
It's not about grade.
We'll
it's about
discuss
choice.
it now. Lizo chooses the middle cup. I'm going to tell him it's not in the right cup. Would you like to change your mind?
Yeah.
I was gonna change and say this. So
That's
do
what
I
I'm
become daddy?
Come on, just trust your guy.
Like
the
just
chocolate.
Everybody
just
should trust me.
like
Got their own
like
life.
this.
I won't swap.
Lizo is swapping. Lizo,
No, I won't
you
swap.
won't swap. Lizo's not swapping. He's walking away. Eh? Lizo, by not swapping,
You won.
you were correct. Okay. I'm going to give 1 point for not swapping. Yeah.
Wait, Rex. I don't think it's fair if the headmaster also try it.
Yes, let's
Yes,
do
man.
that.
Yes.
Yes, man.
Definitely. Lizo, can you come along with us? Mr. Foster. Alright, we're ready. We're ready.
Do you want to play something before I choose?
Nothing at all. It's all about the chocolate. Alright, you've chosen this cup. We're telling you that it's not under that cup.
Okay.
Would you like to change your mind?
No.
Keep in your cup, and unfortunately you're that there is called overriding probability or authority. What have we got here? How many swaps were correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many not swaps? 1, 2, 3, 4, 5, 6. from the relative frequency of our experiment, should we swap or should we not swap? We should swap. But Hunter over there said that once I removed the cup where it wasn't, what does it look like to you guys?
Probability is 50-50.
The probability looks 50-50. But this is what's really deceptive about probability. It sometimes can be a little bit more confusing than what it actually looks like in face value. And we're going to have a look why it actually was a better decision to swap based on the probability of the outcome. The idea of a tree diagram is to help you lay out the situation, to help you make a good decision, or to help you quantify the probability of what's going to happen. So we're going to try and draw a tree diagram for this thing. The reason why it's called a tree diagram is quite literally it looks like a tree. It's got branches coming off it. And we'll have a look how we can analyze the tree diagram now. Guys happy? 3 cups. I could make a choice from one of 3 cups. So I'm going to draw
The left, the right, the middle.
the left, the middle. Left,
Or the top, the middle.
right, middle. Okay?
Really? That's where the middle is?
These are, I'm sorry, you're just going to have to live with it. Okay? We got 3 different options. What is the probability of me or you guys choosing one of the cups?
3.
A third. Good. There's 3 cups. Chance of choosing one of them is 1 over 3. So do you agree that the chance of choosing any one of these 3 cups is equally 1 over 3?
Yes, sir.
Cool. So I'm going to put a little probability here. 1 over 3, 1 over 3, 1 over 3. Now tell me, out of those 3 cups, how many of them was correct?
Only 1.
Only 1. So do you guys mind if I just put under the left cup for now?
Yeah.
The chances are 1 of them was correct, so I'm just going to say this one was true, this one was false, this one was false. So what are the chances of you getting it wrong? 2/3, good. 2 out of 3. Chance of getting you right? Brilliant. Now, we change the game. So what happens is we go through this decision, and chances are at this stage, us getting the chocolate is 1 over 3. Now I say I remove one of the cups. Okay. So let's run through now. What happens with the tree diagram is you have a look at each of the different options and you run through what happens. So if I'm sitting in this tree here and I'm true, how many more choices? So what happens is now I remove one of the cups. What are the possible outcomes?
False, false, false.
Okay, I always remove one of the ones that don't exist. So I can either stay or I change. So I'm going to say
Fold.
stay, change. If I'm true, so I've currently got the cup here, and I remove one of the cups. If I stay, do I win? So there's a 100% chance that I'll win, because we're looking at the chances of us winning. So I'm just going to put a 1, sorry, because we're working in, so 100% chance is the same as 1. If I stay, I'm going to win.
Yes.
Agreed? If I change, I'm guaranteed going to lose.
Yes.
So there's a 0% chance of me getting the chocolate. Do you guys agree?
Yes.
Cool. Let's have a look at the other option. Let's say we've chosen this cup now, which doesn't have the tag. Shanley? Okay, we're choosing the middle cup. The tag is sitting under that cup. I now say I remove this cup. If I change, will I get it right or wrong?
Wrong.
Okay, I'm thinking I'm on this cup. Okay, so if I change, I get it right. So, again, we've got 2 options. We can stay or we can change.
I fold.
If I stay, I get
Nothing.
0. If I change, I get 1. Guaranteed to get it. Again, 3 different options. We're now looking at the last one, which doesn't have it. So it's this branch of the tree diagram. So what we're doing again is, guys, the point of the tree diagram is to visualize it, and we're working through the tree diagram to figure out what the probability is of us getting the chocolate or not. Okay. We now are choosing this one because that's the last branch of the tree diagram. It is false. Again, we say we're removing the other cup. Should I change? What happens?
If you change, you will get it.
Get it right. Shanley? Oh, okay, cool. If I don't change, what happens? I win nothing. So again, my options are stay.
Stay or fold.
And lose.
Change.
If I change, I get 1. If I stay, I get 0. What we're trying to do now is work out from the tree diagram what is the probability of us getting this thing right or wrong. How we can do this is what we can do is, you can see the third sitting there, I've put numbers onto the tree diagram for a reason. Okay? As you work down the tree diagram, what you can do is you can multiply the numbers. If you set the tree diagram out correctly, and it's going to give you a final probability of that exact sequence of events happening. That's the point of the tree diagram. So I can track down the probability of the thing being in the cup that I chose, and I chose to stay, it's then going to be a third, or I chose to change, it's going to be 0. Kind of makes sense? Okay, so let's have a look. What is a third times 1? Just bear with me for now, this will kind of make sense in a little bit. A third, good. What's a third times 0? 0. What's a third times 0?
0.
What's the third times 1?
1/3.
1 over 3.
0.
0 and a third, good. Next to all the changes, I want you to add those up. Sorry? Change, 1 change,
Yeah.
2 changes. So 1/3 plus 2/3 is?
3 over 6.
Yeah.
Sorry? 1/3 plus another third is?
3 over 6.
2/3, good. And plus 0?
It's 2/3.
We're only looking at the changes, okay? Change, change, change.
Oh, okay.
So we're only looking at, because remember, our decision is what happens if we change or what happens if we stay. So if we have a look at change, we got a third, plus another third,
2/3.
plus 0. We got 2/3. So for change, we got 2 over 3. Stay, we got 1 over 3. That's pretty interesting. What does that say about our counting at the beginning here? This is change. This is not change. What is this saying here? We can work out how close to, so we've got a total of 17 events. Somebody type into your calculator, what is 11 over 17?
0.647.
Good, 647 something. 647, type in 2 over 3. Tell me what that is.
Sorry?
2 over 3. You don't have to type in, you should be able to tell me that anyway. Good, 0.666. How close is 0.647 to 0.666?
That is crazy close.
That's very, very close. So, relative frequency gave us a probability of 0.647. Our calculation gave us a probability of 0.666. Okay, 2 things from that. Relative frequency was the experiment. Theoretical probability was our calculation. Also, it was better to change your mind. Okay, again, we can have a look at why, and let's just now try and understand qualitatively why it is better to change your mind. The chocolate was only sitting under one of the cups. Agreed. Okay? If you happen to choose the correct cup first off, which branch do you immediately go into?
The top one.
You go into the top one. If you change your mind, will you, it doesn't matter, if I take away this cup or I take away this cup, will you get it wrong? If you change your mind.
Oh,
Guaranteed get it wrong. That's what this one's saying. Okay? So if you happen to choose the chocolate in the first step, then you're unlucky. But what is the probability of choosing that chocolate in the first step?
1/3.
1/3. Good. Now let's have a look. If you happen to not choose the chocolate, so if you happen to choose either this one or this one, okay, just run with me for this one, and I remove one of the other ones. So if you chose this one, I could remove that one. If you chose this one, I could remove that one. Which one have I not touched?
The one with the
So can you see, it doesn't matter. If you guys chose this one or this one,
Neither.
you're going to get up with the chocolate if you change.
Yes.
But if you chose this one and you change, you only end up with a chocolate. None of them.